All right, so module 3, homework 3, simplifying radicals. We've been talking about simplifying radicals, but let's kind of continue. We have what's called the product rule. Product means multiply. So if we have the nth root of a times the nth root of b, they are both being multiplied together. So instead of writing them with their own nth root, I can multiply them together and say the nth root of a times b. Likewise, the quotient rule. Quotient means dividing. So if I have the nth root of a divided by b, I can split this up and say the nth root of a divided by the nth root of b. So perform the indicated operation and simplify. Square root of 5 times the square root of 15. They're both square roots, so I can write it underneath the same square root. And 5 times 15, which in my calculator, 5 times 15 should be 75. Yep. So we have the square root of 75. So now we can simplify this by itself. So 75 will give us 5 times 15. 5's going to get circled. 15 is 5 times 3. 5's going to get circled. 3's going to get circled. So underneath the square root, we have 5 times 5 times 3. It's the square root, so we're looking for 2 of a kind. So these two 5s are coming outside the radical. And that one poor little lonely 3 is left by itself underneath the radical. So our final answer is 5 square root of 3. Next one, multiply the roots, then give the decimal approximation to 3 decimals. So the cubed root of 13 times the cubed root of 5. They're both cubed roots, so I can write it underneath the same cubed root. So the cubed root of 13 times 5, which is the cubed root 13 times 5, will give us 65. Let's break down 65. So 65 is 5 and 13. Obviously, I guess we just said that. Which 5's then it's can't be broken down. 13's then it can't be broken down. So that means I can't simplify this any further. So the product in nth root notation. So nth root would be the 13th root of 65. And let's plug this into our calculator to find the decimal approximation. So in our calculator, I want the cubed roots. I'm going to type in 3 first. And then if you notice, above this exponent symbol, it has the xth root. So if I do second and then our caret button, so second and then getting that x root, what it's saying is this 3 is going to go where the x is. So it's going to be the cubed root of 65. Press enter. And you get 4.0207 blah, blah, blah. It says round to 3 decimals, so 3 numbers after the decimal. So 1, 2, 3, we're going to round this 0. Looking next door is a 7. Remember, if it's 5 or higher, it rounds up. Anything less than 5 stays the same. 7 is 5 or higher, so that 0 is going to round up. So we have 4.021 as our decimal approximation. Only time we do decimal approximation is when it literally asks for it like this. So let me write a little note on how you plug that into our calculator. So in our calculator, we plugged in 3, and then we hit the second button, and then our caret button. And this gave us the x root. So we can do the same thing. If it was the 4th root, we type in 4, and then we would hit the second caret button. If it was the 5th root, we type in 5, and then the second caret button. And then we typed in 65, and then press enter. And that's how we got to the third cubed root in our calculator. So next example says to simplify 3 times the square root of 150 in the form of a square root of b. Let's break down 150. So I know 150 would be 15 times 10. How are we going to break it down and get the same answer in the end? 15 would be 5 times 3. 5's then it gets circled. 3's then it gets circled. 10 is 2 times 5. 2's then it gets circled. 5's then it gets circled. That 3's out front, it's going to stay out front. Underneath the square root, we have 5 times 5 times 3 times 2. That 3's out front, it's going to stay out front. It's the square root, so we're looking for 2 of a kind. So these two 2's are going to come, these two 5's are going to come outside the radical as just 5. Underneath the radical, we're left with 3 times 2. Those are just, there's not a pair to come out with it, so they have to stay underneath the radical. So we have 3 times 5, which is 15. Underneath the radical, 3 times 2, which is 6. So our final answer is 15 square root of 6. All right, next we have to simplify the fifth root of d to the fourth divided by 243. Using the quotient rule that's up here, I can split it up in where they have their own radical. So I can say it's the fifth root of d to the fourth power divided by the fifth root of 243. Now, this would be d to the fourth power, so d times d times d times d, 4 d's. I'm looking for groups of 5. There's not enough to make a whole group to come out, so I can't simplify that. So just leave it as the fifth root of d to the fourth power. Notice that 5 is a little 5 inside of the radical symbol. And let's break down 243. 243, 2 doesn't go into it. Let's try 3. 3 and 81. So 3 times 81, 3 is going to get circled. 81 is 9 times 9. 9 is 3 times 3. And then 3 times 3. So we have 5 3's. So we have the fifth root of 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. It's the fifth root, so we're looking for 5 of a kind. So these 5 3's are going to come outside the radical. Nothing's up underneath the radical, so the radical is going to go away. And we're left with our final answer of the fifth root of d to the fourth divided by 3. So notice we separated them, so leave them separate. So the radical only goes to the d to the fourth up top. The 3 is totally separate on the bottom. All right, let's go to our next page. So simplify, assume that all variables represent positive values. Do not use a calculator or round to a decimal. We're going to write it in exact form. The cubed root of 64 d to 21st power all over 125 b to 24th power. All right, so little side note. Let me go over here and let's break down 64. We know 64 is 8 times 8, which 8 is 2 times 4. 2 is going to get circled. 4 is 2 times 2. Same thing over here. 8 is 2 times 4. 4 is 2 times 2. So I can break it up and say it's the cubed root of the top, which is 64 d to the 21st power. And now I can break down that 64 and say it's the cubed root of 2 times 2 times 2 times 2 times 2 times 2 times d to 21st power. We can use our little trick of dividing by our index in 1 second. So that's up top. On the bottom, we have the cubed root of 125 b to 24th power. So let's break down that 125. So 125 divided by 5 would give us 5 times 25. 5 is going to get circled. 25 is 5 times 5. So I have the cubed root. Instead of 125, I can write 5 times 5 times 5 times b to the 24th power. We can leave it at the 24th power. We'll use our little shortcut for that one. So it's a cubed root. We're taking out 3 of a kind. So these 3 2's are going to come outside the radical. These 3 2's are going to come outside the radical. And if we have 21 d's, we're taking out groups of 3. We can say 21 divided by our root, divided by our index of 3. That'll leave us with 2 times 2, which is 4. D to the 21 divided by 3, which is 7. Up top. On the bottom, I have the cubed root of 5 times 5 times 5. So we're looking for 3 of a kind. So these 3 5's are going to come outside the radical. Times b to the 24th power. I'm taking out groups of 3, so we can do 24 divided by 3. So I have 5 to the 24 divided by 3 would give us 8. So 8 groups of b are coming out. So divide by 5, b to the 8th power. So this is our final answer. Everything's simplified. Everything's positive. 4d to the 7th divided by 5b to the 8th. So next one, let's simplify. The square root of 108 y squared c to the 8th divided by 9, square root of 9 y to the 10th c to the 4th. Now here, they're both square roots, so I can write it underneath the same square root and say 108 y squared c to the 8th divided by 9 y to the 10th c to the 4th. So now we can simplify. 108 divided by 9 Plug that into our calculator. 108 divided by 9 will give us 12. So I have the square root. We simplify that to 12. I have 2 y's up top and I'm 10 y's on the bottom. Remember, we can subtract these exponents. This would give me y to the 2 minus 10, which is negative 8. So because it's negative, it's going to go to the bottom. So on the bottom, we have y to the 8th power. Because it went to the bottom, it became positive. And then likewise, subtracting our exponents, c to the 8th divided by c to the 4th. I have 8 c's. I'm taking away 4 of them. That means 4 are left over. 8 minus 4 is positive 4, so that means that c to the 4th is going up top. So now we can simplify this. So side note at the bottom, if we have the square root of 12, I can say that's 2 times 6. 6 is 2 times 3. So underneath my square root, we really have 2 times 2 times 3. It's the square root, so we're looking for 2 of a kind. So those 2's can come outside the radical. And that one little poor lonely 3 is left by itself underneath the radical. Or if you want to say, we have the square root of 2 times 2 times 3 times c to the 4th divided by y to the 8th. So these 2's are coming out. We're going to take out c to the 4 divided by 2 because we're taking out groups of 2. So that means c squared is coming outside the radical. Likewise, I have 8 y's, and I'm taking out groups of 2. That means 8 divided by 2 would give me 4 groups are coming out. So the only thing that's left underneath the radical is that 3. So 2 came outside the radical. C squared came outside the radical. Y to the 4th came outside of the radical. It's on the bottom, so it needs to stay on the bottom. But then that poor little lonely 3 is left on top underneath the radical. So this is our final answer. 2c squared times the square root of 3 all over y to the 4th. And if it helps you to write it like in separate fractions, that's fine too. 2 times 2 times 3 times c to the 4th divided by the square root of y to the 8th. So that's why that's y to the 4th stayed on the bottom. Everything else came out. All right, last one. Simplify the radical expression, the cubed root of x to the 7th, y to the 8th, z to the 5th. What's weird here is I notice it's a cubed root, so I'm going to be dividing by 3. But 7, 8, and 5, my exponents, are not divisible by 3. So let's write it out to kind of see what's going on here. So the cubed root, x to the 7th, so 1, 2, 3, 4, 5, 6, 7 x's times y to the 8th, so 1, 2, 3, 4, 5, 6, 7, 8 y's times z to the 5th, so 1, 2, 3, 4, 5 z's. We're taking out groups of 3, so these 3 x's are going to come outside the radical as just x. These 3 x's are going to come outside the radical as just x. That one x is left by itself, so it's underneath stays underneath the radical. These 3 y's are going to come outside the radical as y. These 3 y's coming out. Those 2 y's, there's not enough to make a group of 3, so it's going to stay underneath the radical. These 3 z's come outside the radical. And then those are only 2 z's, so I don't have enough to pull out another pair. So outside the radical, we have x squared, y times y, so y squared, times z. And then underneath the cubed root, we're left over with 1x, 2 y's, so y times y, which is y squared, and 2 z's, which is z times z, which is z squared. So underneath the cubed root, we still had 1x, y times z times z, if that kind of helps you to see it. If you like to do the division, dividing by your roots, dividing by the index. So, or another option for this problem is we can say x to the 7th power and we're dividing by 3, y to the 8th power, we're dividing by our index of 3, times z to the 5th power, we're dividing by our index of 3. This kind of thing takes a little bit more thinking. So if I have x's, if I have 7 x's, I'm taking out groups of 3. So that means 2 groups are coming out. 2 groups of 3 would give us 6. So out of 7, that means we have 1 left over underneath the radical. For my y's, I have 8. I'm taking out groups of 3. So 8 divided by 3 would give me 2 point something. So that means 2 groups are coming out evenly. 2 groups of 3 would give us 6. So 6 out of the 8, so that means 2 are left over. So y squared. Lastly, if our z's, if I have 5 and I'm taking out groups of 3, that means 1 point something. So 1 group's coming out, so 1z. And 1 group of 3 is just 3. So out of my 5, 3 are accounted for. That means 2 are left over underneath the radical. So you get the same thing of x squared y squared z times the cubed root of x y squared z squared. However you want to think about it, totally up to you. So that is all of Module 3 Homework 3. You can now do the Module 3 Homework 3 assignment. If you have any questions, please let me or one of the tutors know. If not, thank you very much for watching.